Yo, 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 what's up? It's Mr. G here, and this is the video for linear inequalities. Now, what we are going to be doing is we are going to be solving linear inequalities, and we're going to do it by graphing. Okay, so this is really the only way to do it, and so we're going to figure out what the solution is by graphing them on a coordinate plane. So we're going to start off with by looking at this really simple equation of y equals 2x plus 2. If you look at this, is just a linear equation. Okay, so you're going to be graphing this linear equation just like you've always graphed it. So y equals 2x plus 2, I'm going to start on my y-intercept of positive 2. And then I'm going to use my slope of 2 over 1 from that y-intercept. So up 2 over 1. Up 2 over 1, up 2 over 1. I'll go down 2 over 1 just to go the other way. Down 2 over 1. So there is my graph. Let me see if I can draw a line through this. Nice. Not bad. Okay. Simple, right? So when we're graphing linear inequalities, we're going to do the exact same thing as we do with linear equations. So I'm going to graph it the same way as I just did here. So let's look. Instead of having y equals 2x plus 2, now I'm going to graph y is less than 2x plus 2. So again, it's the same exact graph because now I have an inequality symbol instead of an equal sign, but it doesn't change anything. So I'm still going to start on my y-intercept. I'm still going to go up 2 over 1 each time. I'm still going to go down 2 over 1 each time. Okay. Now, what's going to change though is that instead of using a solid line, I'm going to use a dashed line. And I'm going to show you a trick as to how to help remember you when to use a solid or dashed line. But to give you guys a heads up, the reason why we're using a dashed line is because there is no or equal to symbol underneath our inequality. If it had the or equal to symbol, we would use a solid line. Okay? But instead, because it doesn't, we're using a dashed line because that means anything on this line is not included in my solution because y has to be less than the values that are on this line. So, one thing we know about inequalities is inequalities have multiple solutions to them. So y can be anything that's less than this particular line of 2x plus 2. Well, there's a lot of things that are less than the line of 2x plus 2. So what we're going to do is we're going to shade in the side of the line in which all of my possible points could be a solution to this particular inequality. Okay, so what I mean by that is that if y is less than 2x plus 2, what I'm going to do is I'm going to figure out, is everything below the line less than 2x plus 2 or everything above the line less than 2x plus 2? Okay, and so the way we can do that is we can test a point. So if I always like to look at 0, 0, okay, I'm going to look at this point 0, 0, and I'm going to see, is 0, 0 a solution to this inequality? So I'm going to plug it in. 0 is less than 2 times 0 plus 2. And if this is a solution to this inequality, that means every single point on this side of the line is a solution to the inequality. I always test the point 0, 0 when I can, because if I can't test the point 0, 0, if it's on 0, 0, then I'll test 1, 1. I always like to use simple numbers because 0, 0 is really easy math. 0 is less than 2. Is this a true statement? Is 0 less than 2? Yes, it is. That is true. That means that 0, 0 is a solution to this particular inequality. 0, 0 is on the bottom half of this line. That means that everything on the bottom of this line, all of these points underneath here, are part of my solution. So I'm going to shade in everything underneath the line because all of these points would make this inequality a true statement. Okay? And let's look at, again, y. Let me test the point that's above the line to show you how it does not work. So let's just stay on the origin and make it stay on the y-axis to make it simple. Let me test the point. I'll do it in a different color. Let me test the point 1, 2, 3, 4. Let's test this point. Okay, this is above the line, clearly above the line. So let's test the point 0, 5. So if y is 5 and x is 0, is this going to be a true statement? Would this be a solution to this particular inequality? So I have 5 is less than 2. Is this true? No, it is not true. Therefore, this is not a solution. So again, that means I wouldn't shade on this side of the line because nothing over here is going to be a solution because y has to be less than. Okay, so there we go. Less than means we're going to go below the line, and I always test a point to make sure. So this was kind of a bunch of nonsense. Let's get this all in a couple steps if you would like. So we're graphing linear inequalities. We graph like a normal equation. That does not change. We determine if it is a solid line or a dashed line. Here is a little hint that I can give for you. I've had you guys make these faces before. So whenever we have a less than or greater than symbol, whenever we graphed it on just like a number line, we always used an open circle, right? Because that was showing that open circle, that was saying that it wasn't included in my solution. So we use an open circle, that's the nose, and then we also use a solid line. So here's a face right here. Here, I can put a circle around it. Oh man, I messed up in my circle though. No. There you go. So you can put a circle around it, give it some spiky hair, that's fine, some ears. Okay, there's one face. Now, if I have a, if there's the or equal to symbols underneath though, so I less than or equal to, we use a closed circle on the, oh, I messed up my line, no. I'm not gonna edit this, so you're just gonna have to fix it. Sorry guys, this is just like having me, it's gonna be a dashed line, that's what we just did. It's a dashed line because that means this is not included in my solution. So whenever we have a dashed line, that means anything on that line is not included. That's why it's a broken line, not included. So if you have the no or equal to symbol, that means we do not fill in the circle on a number line, which also means we have a dashed line. We're not filling in the line on the plane. My bad. So then if it has the or equal to symbols, then it's going to be a solid line. And there's another face that you could have. Okay, and again, maybe this one is like has nice curly hair. Okay, this is the worst face of all time, like person. Like it's supposed to be a person, but it looks like it. Anyways, this is terrible. But you guys get the idea. Okay, so you can draw those faces. That might help. But again, if it's or equal to solid line, not or equal to, if it's just less than or greater than dashed line because they're not included, then we test the point to see which side of the line to shade. Okay, so go ahead and try this one on your own. I think you guys can do it from the get-go. So give this one a shot, pause the video, test it, see how you do. Okay, so hopefully you just unpause it and you've already graphed this, but I'm gonna give you guys a joke real quick. What keeps a square in one place? What keeps a square in one place? Square roots keep a square in one place. Square roots. Nice. Okay, so start with my y-intercept, +1. There we go. Negative 1/3 x, down 1 over 1, 2, 3, down 1 over 1, 2, 3. I can keep going. Up 1 over 1, 2, 3. We definitely want to go both sides. Up 1 over 1, 2, 3. And again, do we have to make it this long? Probably not. There's no way I'm going to be able to connect this well. I know it's a solid line because it has that or equal to symbol underneath. It's definitely a solid line. It should be much straighter than that, but you guys get the idea. So it's a solid line, not a dashed line because I have the or equal to symbol. Now I just got to figure out, do I shade below or above? It says y is greater than, so we're probably going to shade above, but I want to be sure, so I'm still going to test my point of 0, 0. So is y equal less than or equal to, I'm sorry, is y greater than or equal to negative 1/3 times 0 plus 1. So 0, is that greater than or equal to 1? No, 0 is not greater than or equal to 1. 0, 0 is not a solution of this line. So that means everything above the line is a solution. So that means all of this can be shaded in. And you guys can just shade it in nice and light with your pencil. Okay, it doesn't need to be shaded in super dark. Just a nice light shade. Okay, don't break your pencil. Okay, another one. So this one you can try this one on your own. Might look a little bit different, but it's not going to change what we do for as a process for how we solve these. So first of all, I'm gonna solve for y because when we graph linear equations, we want to have our y by itself. So I'm going to divide by 3 on both sides. Now when I divide by 3, I get y is greater than or equal to -3. So if I asked you guys to graph this on a number line, I would be at -3, -2, -1, -4, -5, and you would do a closed circle, y is greater than, so it would be shaded to the right. So this is going to be pretty similar to what we're going to do, but now we're just going to graph it on a coordinate plane. Okay, so if I have y is greater than or equal to -3, I'm going to start at 1, 2, -3. There's my y-intercept, there's my point, right? I'm going to determine, do I use a solid line or do I use a dashed line? Well, it's solid, but the graph for -3, if it was y equals -3, I would just have a horizontal line. Okay, and yes, this is horizontal, not vertical. Okay, and so I have a horizontal line at y is -3. And then if y is greater than -3, which values are greater than -3? Well, this one's pretty easy to shade. It's just everything above. Everything above -3 is greater than -3. So this graph right here is pretty much the same thing as this graph. This is just representing it on a coordinate plane. So there you have it. And again, it's a nice light shape. All right, last one, try it. And then this is the final problem example in your video. Graph it, please, and then make sure you got this down. Okay, so I'm at 4x minus 3. So I started at negative 3. 1, 2, 3. Wait, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I'll go down. 1, 2, 3, 4 over 1. And there's my straight line. Yikes. It's hard to do this on the slate. Okay. So I'll test my point 0, 0. Y is less than. I already made a mistake. What mistake did I make? I did not do a dashed line because we know it's dashed because there is no or equal to symbol. So let's go ahead and fix that. Be careful. That's why step 2 is always check to see if you have a dashed line so we don't make simple mistakes like Radia's just made, but at least I caught it right away. So I've got my dashed line because it's just less than. Now, because y is less than, I'm guessing we're going to shade below, but let's test the point 0, 0 to make sure. If I plug in 0, 0, is 0 less than negative 3? No, it is not. That is why that is not a solution. 0, 0 is not a solution on the line, so that means that everything below the line on the right side is going to be a solution. And then, so all of this is solution. And again, if you guys wanted to make sure you checked it, once I checked 0, 0 and it didn't work, I can pick any point on this right side to make sure it works. So let's pick this point right here. Let's just make sure this is a solution to inequality. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when x is 10 and y is 0, when x is 10 and y is 0, is this a solution? 40 minus 3 is 37. Is 37 greater than 0? The answer is yes, it is. It is a solution. It worked. We're good to go. All right, guys, that's it. Hope this video helped. Let me know if you have any questions. Good luck, and thanks for watching. Later.